So welcome to my mathematics videos, O-level mathematics. As we continue in our discussion, as we look at calculus, I want to show you some few concepts that you're going to be finding in your ECZ, examination council of Zambia. So we are going to look at, equations. So we are going to look at how to find equations of tangents and normal. So how can you get the equation of the tangent and normal? So that is what we are going to look at in our discussion. Now, of course, if you still remember from your coordinate geometry, if I can just remind you from your coordinate geometry, you still remember that it is possible to find the gradient by simply saying y2 minus y1 over x2 minus x1, the change in the y step divided by the change in the x step. Of course, this was applicable when you are dealing with what we are calling as being a straight, you are dealing with a straight line. This is very much applicable. But of course, if you are dealing with what we are calling finding the gradient of a curve, for example, if you have a curve and you want to find the gradient of a curve at a particular point, at any one particular point, for example, maybe this point here I've labeled A and you find the gradient. How do we find the gradient? Well, we find the derivative dy over dx. So our gradient m is actually given by our dy over dx. So the change, the change happening in the y-axis divided by the change that is happening in the x-axis. So those small increments that are going to be happening. So now when you're dealing with a curve, you are going to be using dy over dx to find the gradient at a particular point. Of course, they are going to give you the coordinates at a particular point that you can use to find the specific, gradient. Now, another thing that you need to remember is that when it comes to finding the equation of a line, you need to remember that the equation of a line can be given by y is equal to mx plus c, where m is representing what we are calling as being the gradient, and our c there is representing what we call the y-intercept. And of course, what do we mean when we say y-intercept? Well, if you're dealing with a straight line, remember it is a point where the line is cutting the value, the y-axis. What is the value of y where the line is cutting the y-axis? So that is what we call the y-intercept. Or you can apply and simply say y minus y1 is equal to m multiplied by x, minus x1. So you can also either use this or that one. But in my discussion, I'll focus on using this one. Remember, this formula is actually coming from the formula for the gradient. You can just cross multiply. It's more like we are having that. All right, we did teach you under coordinate geometry again about what we simply called as being perpendicular lines. So for perpendicular lines, we did say if you have a line sloping in that direction and you have another line sloping in that direction, these are meeting at 90 degrees, they are perpendicular. Let's say the gradient of this one is m1 and the gradient of this one is m2. Now remember, for lines that are perpendicular, when you multiply the gradient of m1 multiply by the gradient of m2, that will give you a negative 1, and that's the concept that we want to take, especially as we deal with our calculus, because we are going to be dealing with the curve. So now let me show you using this concept how we can simply try to apply that. So like I said, under calculus you are going to be dealing with curves, and of course the gradient of a curve is not just going to be 1, it will keep on changing, and that is why we need to apply calculus, which accounts for a change. So now imagine that you have a point there, I'm calling A. If we were to draw a tangent at this particular point, well, the tangent will look something like this. So touching just the curve at this particular point that we have, let me call it in this case as being point A. This line that I've drawn is simply what we are calling as being the tangent. But of course, if you are to draw a normal, it is a line passing through that point or meeting the tangent at 90 degrees. I know it doesn't look like one. Let me just try to use a rule so that you are able to at least appreciate that. So now when you draw a line in that direction, passing through the same point, but meeting the tangent at at right angle, this is what we simply call as being the norm. That is what we call as being the normal. So what should you remember about the normal? Well, imagine that the gradient of the normal, of course, when a line is sloping like that, you know that the gradient is always positive. When a line is sloping like this, you know that the gradient is always negative. So in the case of the normal and the tangent, it follows that the gradient of, imagine that you have the gradient of the tangent, and let me say, you know the gradient of the normal there. Let me say the normal. The way it is that the gradient of the tangent multiplied by the gradient of the normal, it should be equal to -1. Why? Because they are going to be meeting at right angle. So therefore, we can tell you to find the gradient of the normal. So what are we going to do to find the gradient of the normal? Or you can make a gradient of the normal subject of the formula to be -1 divided by the gradient of the tangent. So that's the way we are going to be doing to find the gradient of the normal. Now remember, when you're dealing with a curve, the gradient is simply given by dy over dx. So we could modify this one and say, oh, the gradient of the normal is simply -1 divided by dy over dx. That's what we mean there. So there's nothing really complicated about that. Okay, so we are going to apply this concept in just a short while. You'll be able to see that. But of course, I want to start with a question. For example, let's put up an example there. Let's say that they tell you to say that find the equation. They tell you to say find the equation of the tangent. Yeah, find the equation of the tangent, and let's say find the equation of the tangent and normal to the curve. So let's say to the curve y is equal to x squared minus 3x minus 4 at the point where x is equal to 2. Of course, when we know at the point where x is equal to 2, we can know what is the value of y by replacing in the equation of the tangent. Now, how do I find in this case? So I'm finding two equations, the equation of the tangent and also the normal to the curve. So how do I find the equation of the tangent and also the normal? Well, it's very simple. What we are going to do, we are going to get the equation of the curve y is equal to x squared minus 3x minus 4, and we are going to find the derivative dy over dx. So dy over dx, remember, when you are differentiating, you multiply the index by the coefficient, so that will be 2x, then the index reduces by 1, minus there, when you have a number and a letter, you just remain with the the number. The constant is always 0, so we can ignore it. Now remember, they told us we're at the point where x is equal to what? X is equal to 2. So I'm going to find the gradient dy over dx. What is the gradient when x is equal to 2? What is the exact gradient? So we are going to replace there. So it will be 2 times 2 minus 3. So that will give us 4 minus 3, which will give us a gradient of 1. So that is what we're having there. So at that point, the gradient is equal to 1. So the gradient that we have found there is simply the gradient of the tangent. Therefore, I'll say the gradient of the tangent is equal to 1. So that is what you need to remember there. Okay. So now, when we find the gradient of the tangent, before we can find the equation of the tangent, I'm first of all going to know, they told me that when x is equal to 2, I need to know what is the value of y, which we do not know. So we are going to replace in that one. So it will be y is equal to x squared minus 3x minus 4. So it will be y is equal to x is simply 2 raised to the power 2 minus 3 times 2. minus 4. So that will be y is equal to 4 minus 6 minus 4. So y is equal to, that is going to give us still a negative 6. So meaning when x is a 2, your y is simply a negative 6. So once you get those coordinates now, it is now possible for you to know the equation of the tangent. Why? Because you know the gradient of the tangent is a 1 and you have the coordinate 2, negative 6 there. So that's what you need. So using the equation of a straight line, y is equal to mx plus c. So how is that going to be? So we need to find the y-intercept. This will be the value of x, that will be the value of y, and we'll replace on the gradient so that we can know the y-intercept. So what is my y? It's negative 6 is equal to the gradient, it's a 1. The value of x is a 2 plus c. So it will be negative 6 is equal to this times that is a 2 plus c. This will give us, the 2 will go the other side like terms. That will be negative 2 is equal to c. So negative 8 is equal to c. So therefore, if c is that, then it simply means that the equation of tangent, so the equation of the tangent is going to be, we'll replace the c and the gradient into the equation of a straight line. So how is that going to be? It will be y is equal to, remember my gradient is 1, 1 times x will just be x. My y-intercept is negative 8, therefore here it will be minus 8. So that is the equation of the tangent. This is what they wanted us to do there. So very important that you get to appreciate that concept. This is a question that came in one of the final exams for ECZ, so you need to watch out. Now let's find the equation of the normal. I've extended the question by finding the equation of the what? The equation of the normal. So how do you get in this case? So I'm looking for the equation of normal. So for you to get the equation of the normal, you need to know the gradient of the normal. Remember we said the gradient of the normal is equal to negative 1 divided by the gradient of the tangent. So do we know the gradient of the tangent? It was 1. So negative 1 divided by 1 will still give you negative 1. So you are going to use the gradient of the normal, which is negative 1, and these coordinates that we have, 2, negative 6, to find the equation. So again, we find the y-intercept. Y is equal to mx plus c. This is my x, my y, so we replace there. So what is my y? Negative 6, the gradient negative 1, and what is my x? It's a 2, in this case, plus c. So that would be negative 6 is equal to negative 2 plus c. Like terms, this when it goes the other side, the sign will change to be a positive 2 is equal to c. So that will give you negative 4 is equal to c. Therefore, the equation, so in this case, equation of normal, the equation of the normal will be y is equal to, so you replace where there's a gradient, it's negative 1, so it will be negative x. The y-intercept is a minus 4. So that is what we mean there. So this is the equation of the normal that they wanted you to get. Watch out for more practice questions on this one as we try to show you how you can find the equation of the tangent and also the normal.